So I'm very happy to announce that we have two new products since the last European UGM. JChem Choral, which is an Oracle cartridge, and JChem Microservices. As you may know that we started with the JChem base, which is a very nice searching tool, and then we developed the JChem Oracle cartridge, which since then became the industry standard. And in the last 3 years, we developed this new search engine, which is based on the old one as well, but has very nice features. And 3 years ago, we came out with the JChem Postgres cartridge, which is already using this new search technology. So this year, on probably March, we released the JChem Choral, which is the JChem Oracle cartridge with the new engine behind it. And this is already having all the nice features which this tool is providing us. And also, end of last year, we came out with the JChem Microservices having these feature sets. Okay, what are these feature sets that I'm going to talk about, and what is probably very interesting for you? First of all, it has the hit as you draw functionality. I think this video does more than I can tell in words, that while you are drawing your structures, the quick hits instantly appearing as you draw. When I talked with chemists, they really like this functionality. But what we had to do to be able to provide this functionality is actually two things. First of all, is we had to create fast searches with a hit limit, because people cannot handle more than a few hundred structures, so they are not interested if they get back 1 million structure. And the other one, which you can also see on the demo, that the hits are ordered according to the similarity to the query structure. Also, we are just get rid of many of the options. In the JChem base and the JChem Oracle cartridge, we have more than 60 options. And then instead of having these 60 options, we were rather focusing these hits according to the similarity and transformations, where you can, for example, search for your structure, getting rid of the stereochemistry. I have to emphasize that, however we get rid of these options, we still have the tautomerization handling and also the query properties on atoms and bonds. What else do we have in the JChem Choral? First of all, we heavily improved the speed of the search when you are joining chemical structure search with non-chemical filters, which is in the same table or which are on different tables and you are joining it. The other nice feature is that we are handling larger databases, I mean chemical structural databases. So in the JChem base, let's say we are handling millions, multi-millions of structures. However, the Choral is just an order of magnitude, tens of millions of structures. And finally, what is a technical emphasis, that it supports Amazon relational data store. How many of you are familiar with Amazon Relational Data Store? Okay, few of you. Okay, then just in a nutshell, this means this is Amazon is providing you a relation database, and all the management is handled by Amazon. So it removes your burden from your database administrator. Okay, go to the JChem Microservices. The JChem Microservices have all these nice features, but when we were moving from the monolithic JChem web service to the JChem microservice architecture, that we are focusing on the modularity, then you don't have a monolithic version, but have small modules, I will show you later, scalability, easily manageability, like orchestration service, and highly availability thing. If we have all these 4 features, I would say that this microservice is a cloud-ready solution. These are the currently available modules. So these are the small microservice modules: IO structure manipulation, chemical property calculation, Marcus stateless, which is the Marcus enumeration, and DB search. You can see that we have stateless and stateful modules as well. And we are currently working on the highly available DB search module, And if we have that, that's also going to be cloud ready. In the plans, we will also would like to cover all the monolithic service functionality. These are in our plans. And you probably see that we might come up with a web service interface for the different cartridges. If you are interested in this feature, please discuss with me, because I'm really interested in how many of you are using these features. Okay, these were the very interesting and news, but this is not just what I wanted to talk about, because we are doing projects and experiments inside ChemAxon. We are using these tools to provide you some very interesting features and projects. Project Haystack. Project Haystack is an interactive and standardized handling of internal and public databases. So you have your compound repository with, let's say, 3 million structure, your internal screening library, again, few million structure, and then you go with some external databases like Campbell or BindingDB, where you have some biological information, Sure Campbell, where you have the IP information, and you may want to use e-molecules, Namiki-Shoji, PubChem, and also Molport for compound databases, compound sources. And finally, let's mention that also Enamine, which is now it's more than 680 million structure, and you want to access this with a single interface. That is this project all about. And Ivan Schott is going to speak about this one in the next day. This predictive search and drawing you have already, oops, I should. Okay, the video is not going. Can you start the video? Maybe you have to click on that. Okay. So this predictive search and drawing tool is based on a database, and it is predicting you what type of structures can you expect from the database. And we will have also a discussion about this one. And finally, a little bit more detail about graph databases. This is a new technology even for us. So until now, we were working on the relational databases, let's say, era. But since the last few years, we heard about that graph databases are coming out in knowledge graphs and different questions. So how many of you are familiar with graph databases? Oh, are you already using it for some? No, not yet. Okay, for the others, in the graph databases, you have nodes and you have relation between the nodes, and you can imagine such a graph database that, for example, a structure is a node, a document is where you get the structure from, you can have an activity with the structure, and you can have calculated values, and these are the relations which are making the connections between specific nodes. The very, let's say, yes, a nice feature of this graph database is when you want to add an additional node, like molecule weight for all of your structure, you don't need to add an additional column for the table, but you can modify very easily the database without corrupting your original data. It also has a query language, which in case of Neo4j is a Cypher query language. Your question could be that, oh, this is an even more complex database, let's say schema in a graph database. Why would some use graph databases if we have already the well-known relational database schemas? Typically, when you are going from relationships to the structural data, so you're not going from structural data to some additional data, but you have some relationships among the data. For example, this is the Campbell data set, and you want to get information based on the relationship. Another example, when you are joining multiple tables, like the molecule tables, experimental data, activity data, target data, and you want to join these, let's say, 3 or 4 data based on specific criteria, like molecular property information, of course, molecular structure, and activity or targeting ID. These typically joint statements are very slow in relational databases, while it's extremely fast on graph databases because, as you remember, the nodes have direct information for this data. Okay, what we have done in ChemAxon to provide help and chemistry in graph databases, we created the substructure search and similarity search of set of nodes, and we created functions. We were extending for example, the Neo4j language. We can create a set, then you can put chemical nodes in this set, and then we can search on this set. So this functionality is kind of an index mode search in graph databases, sorry. To sum it up, that we have this nice new technology, Choral, Microservices, new search engine, Neo4j Cartridge, and we will have a more detailed explanation from, for example, the Choral API will be explained by Zsuzsa Szabó on the development workshop. Ákos Tarcsai will compare the Choral speed with the Postgres speed and the JChem Oracle Cartridge speed. The Haystack project is based on Postgres Cartridge and JChem Microservices. The new search engine is used by the predictive search and drawing. Tamás Varga will have a small session tomorrow about that. And finally, the Neo4j Cartridge, Zsuzsa Szabó will speak about again just later on the developer workshop, and I will substitute Dragos Stefanescu for the graph database at Sanofi project. I think that's what I wanted to share with you, and I'm really happy to see you and let you know that we have these beautiful new tools. Thank you for your attention.
Can existing cartridge users test the new version already?
Yes, I would be happy to give you that. Great. And I have a very good news for you, that we are missing the call JChem password execution from the new cartridge.
Oh my God, after all these years.
Yeah, you were waiting for this for years now, but now we have it.
Great.